Good morning, everybody. Welcome. Cool. Just a couple of housekeeping things, but before I start, so my name's Cruzan Manuel from the AWS team. Great. So housekeeping things, if we can make sure that all your devices are on silent. If you look out to your left, my right, you will see that there's an emergency exit all the way out over there. If you need the bathrooms, look out all the way to the back and your second exit to your right-hand side. Great. So before we get started and into fun, right, I would like to invite onto the stage. We've got Larissa Becker from the AWS team. And the session title for today is Optimize Amazon SageMaker Deployment Strategies. Over to you.
Good morning, everyone. Can you hear me? Do you need to mic? Perfect. Yeah, welcome, everyone. So early morning. Hope you're all awake. Yes? Okay. My name is Larissa. I'm a specialist BD for AI/ML. I'm joined today by Will, one of our principal SAs. And we are very happy to be here on stage with Alberto. He's product manager at Docebo and will tell you a bit about how they use SageMaker to implement their deployments. Session title today is Optimizing Amazon SageMaker Deployment Strategies. This is a level 300 session, so we do expect you to have a basic understanding of SageMaker. We also expect you to be aware of machine learning terminology. Okay, let's get started. Let's jump right in. Why is this an important topic? Gartner says by the end of 2024, about 75% of the enterprises will be shifting from piloting to operationalizing AI/ML. That means we are really moving out of that typical experimentation phase into a situation where machine learning will be part of products. First step towards that is deploying your models efficiently. Short recap of why our customers are using SageMaker. On the one hand, it's a platform bringing together data scientists, business analysts, as well as machine learning engineers and developers. They do so by really covering the entire end-to-end workflow, starting from accessing data to preparing data to building ML models, all the way to training and tuning your ML models and to deploying and monitoring your models. Starting with things like features that help you do experiment tracking, that help you do model monitoring, help you do parallelizing your hyperparameter tuning jobs. Another reason why customers are choosing this is the resources. You can choose how much resources you need for training. You can split that for deployment, and we'll be covering a bit more about that later. And then we're also having the ability to deploy your models and have different strategies to do that. It gives you all that choice. You can deploy your models in basically one line of code. And then it will also let you put all of that in workflows, data pipelines, retraining pipelines, inference pipelines, all of that automated. And this is the last part we will be focusing on today, deploying your models and monitoring those. So this is the situation we had for the last couple of years, and we saw that with our customers time and again. Data science teams, development teams that would be working on their model, trying to tune the accuracy, get it a little bit better. And then on the other side, we had the business teams that really wanted to see some output. They wanted to see a product. They wanted to use something from that. And we had kind of a discrepancy between those two. So the business would come at one point and say, maybe we should put this in an endpoint, should we? Well, maybe. It depends. If you look at some of our most mature customers around MLOps that have multiple models in production, that have done that time and again, we see that the main drivers of cost and complexity is not training, it's actually predictions. Only about 10% of that complexity and cost is actually coming from the training. It's 90% of that that's coming from the predictions, and this is why this topic is so important. So what are the considerations you want to take when you decide on how to deploy a model? Those have business reasons on the one side, and then there's also considerations around engineering. When we look at the business reasons, we often look first into things like latency, throughput, variable workloads. Think of a recommender engine, for instance. You really don't want your predictions to show up 5 minutes after the customer entered the website. You want them to be there in time. If you have more customers on the website, you want your deployment to be able to scale. If you're looking into costs, you might have a budget. You probably want to monitor your costs. And you probably also want to control these costs. Then move more towards engineering decisions. It might be a question of compute. You might want to decide what kind of CPU you need, how much GPUs, AI accelerators. You want to think about management of infrastructure. You want to make sure that you're efficiently utilizing your compute. And we'll tell you all about that later, even in a demo. We'll also look into your data. You might want to collect your data. Maybe all of it, maybe just a part of it. You might want to make sure that the payload size is right, and you want to make sure that you don't have data drift, so that your model stays up to date as well and isn't outdated. And then lastly, if you look into models, you might have multiple models. You have pre-processing steps and training steps. Do you want to do that on one endpoint, or do you want to do that on multiple endpoints? You want to have a look into size, runtime, and frameworks of your model. And lastly, you want to make sure that your model gets updated regularly and you're able to do A/B testing on it. Think of the recommender engine again, really important that you're able to measure your success here. Now, I told you a lot about why we're talking about this topic. We'll tell you all about how to do that.
Good morning, everyone. I need to put it down a bit. Just quick show of hands. How many people here develop machine learning models or work on developing machine learning models? Awesome. How many people actually took these machine learning models and put them in production settings and started to leverage them with the downstream applications? That's a really good number. So what we're actually going to try to do today is to show you multiple different options, multiple different deployment strategies where you can leverage SageMaker in order to do or take that last step of taking your model that you trained into production, and while optimizing on the performance and the cost of the overall 90% that Larissa was talking about. So SageMaker is a fully managed machine learning service that provides you what you need in terms of model deployment. It's really easy to deploy machine learning models in the cloud with simple API calls. You can deploy models that are trained outside of Amazon SageMaker, or you can use models that are trained within SageMaker, or you can even use some third-party models, something like Hugging Face Model Suite. And it also supports some two broad types of scoring. So it supports online scoring and it supports offline scoring. So online scoring is designed for low latency, real-time inference at scale, while offline scoring is more designed towards high throughput for large data sets, if you have a massive, big data set to make an inference from. And then being fully managed, SageMaker takes care of the web server framework, infrastructure to set up, and anything really like load balancing the traffic between all of the instances behind the endpoint. And as you can see, some example SDK here, you just literally 2 lines of code, model.deploy. You pass in some information about what you need behind this endpoint, like number of instances, the size of that instance, and then you can make predictions right away using your data. So if model deployment is that easy, what is the big deal, right? Like, have you ever thought about or asked yourself the question, should I do online scoring or offline scoring? What are the size of the instance that I should use? How many instances should I use behind that endpoint? Or even, how can I guarantee to have a single-digit millisecond latency response out of my endpoint? All of these questions we're going to try to answer in the next few slides. So the first deployment option is SageMaker Batch Transform, which is basically an offline scoring mechanism. It's asynchronous batch inference that allows you to make machine learning inferences on a bulk of large data against your model. All you need to do is just bring your model, bring your inference script, and then start making predictions right away. It is designed to work on large data sets, basically because behind the scenes, we have a mini agent that takes your large data and automatically tries to do mini batching for that data set in a way that is optimized with the instance behind this endpoint. And that usually gives you really high throughput out of that batch transform job. And then as a fully managed feature, SageMaker takes care of the instance provisioning, deprovisioning, which is automatically done for you. And you only pay for the compute instances for how long the process took to process your data and make predictions. Usually it is suitable for bulk periodic kind of data inferences. You can schedule jobs or you can trigger them right away. And in a use case where batch transform might be useful, something like forecast demand generation, something like recommendation engine for email campaigns, where you don't really need real-time or instant response. But sometimes you need that kind of instant response. And that's where you can use SageMaker real-time inference. So real-time inference in SageMaker creates persistent, long-running process using microservices with HTTPS endpoints and RESTful APIs that you can use and invoke. Being fully managed, SageMaker sets up compute instances and serving frameworks. It also sets up HTTPS endpoints and manage the load balancing automatically for you for the traffic to the endpoint. All you need to do, again, bring your model and bring your inference script, and we will handle everything in the back end. You can provide instance with response time up to 60 milliseconds. So the processing that happens inside the instance can only happen up to 60 milliseconds. And for payload, up to 6 megabytes, right? And then as your business grow and your customer base grow, you might need to build some kind of scaling mechanism. So for real-time inference, you can use automatic scaling, which is similar to auto-scaling groups, to automatically increase or scale in and scale out the number of instances behind this endpoint as you start to receive more and more traffic. Now, some code examples here. So in order to deploy the real-time inference, all you need to do just on your model that you trained, called deploy, pass in a few information, and then start making predictions, which is the same code example that you've seen in the first slide. Now, real-time inference is really great. So, but sometimes you have payload that is more than 6 megabytes, or the processing time can take more than 60 seconds. And typically in cases where you have natural language processing models or computer vision models, and specifically for something like high resolution images, where the image is usually more than 6 megabytes, or videos. In that case, you can use something like asynchronous inference, because you'd like to process and make the predictions in an asynchronous way. So asynchronous inference is a new SageMaker model deployment option that was released late last year. It is ideal for models that takes more than 60 seconds, up to 15 minutes to process, and for payload size that is more than 6 megabytes up to 1 gigabyte size of payload. And that's to process and generate results, which will not be possible for something like real-time inference. So the asynchronous inference even supports auto-scaling all the way down to 0 instances, so that you don't really have to pay for any compute resources while not using this inference endpoint. And then optionally, you can provide some kind of Amazon simple notification service or SNS topic to notify you upon the success or failure of your process. So the way or the mechanism that makes it happen and enable the long processing time for this type of inference is that we have an internal queuing system. So all you need to do, and instead of sending a payload, the actual payload, you upload that payload into an S3 bucket, and then pass in the link for that file, and then that goes into an internal queuing system inside the endpoint, and then we start processing this queue one by one, and then put back the results into an S3 bucket, right? So that's why you need some kind of notification system that shows you when the processing has finished. Again, sometimes you have a really small payload in some situations, and you'd like to not worry about the scaling, not worry about having to manage all of the resources behind the scenes, but real-time inference is not really suitable for that use case. So in other words, you'd like to process or make an inference in a serverless way. And that's where SageMaker serverless inference comes in place. So serverless inference is a brand new feature in SageMaker that lets you host endpoints for model inferences. It can automatically start and scale compute resources based on the traffic, which means that you don't really have to manage any instances under the hood, and you don't really have to do any kind of scaling and all of that. So this specific option is ideal for unpredictable traffic and workload that can tolerate some kind of cold start. Because the first time you make an inference to this serverless endpoint, it's going to take slightly more time to spin up all of the resources and the compute instances. Again, to set up, all you need to do, you've seen the patterns so far, import the SageMaker library. The only difference is you need to define the serverless inference configuration, pass in a few parameters like the size of the memory and the maximum concurrency limit on this endpoint, and just call the deploy command, passing in this configuration, and then you're gonna be able to make predictions right away with your data. All right, so as machine learning portfolio grows, you need to start thinking about the cost for hosting these models. As an example, as you grow your business, you might need to train a model for each geographic location that you're expanding to. And by default, you're going to think about hosting a single model behind a single endpoint in that case. Excuse me. And this is really not ideal, especially if you have models that are not frequently accessed. So you're going to have a lot of resource underutilization for some of these endpoints. So there are two more SageMaker deployment options that you can leverage or use. One is called multi-model endpoints, and the other one is called multi-container endpoint. They are really designed to work with multiple models behind a single endpoint, and then SageMaker automatically manages the loading and unloading of these models in memory of that specific instance on your behalf, so that you don't really have to worry about managing the resources of your instance. So the first one, multi-model endpoints, that can host multiple models in a single container. And with the right invocation to the target model, you'll be able to generate some results. So improve resource utilization, as I mentioned, for models that are less frequently used. And it can share the instance memory between multiple models. You only need to put all of the data into a dedicated S3 location, and then multi-model endpoint will automatically and dynamically load models when they are triggered or requested to be loaded, right? So for example, here I'm calling model number 7, start to use that model, and then I haven't used it for a long time, then automatically SageMaker is gonna unload it from memory and then try to load another model in memory. Okay, so if you're, this is really good design if you have a lot of models that are equal in size and equal in accessibility, like you frequently trigger them. If you have a model that is significantly larger and you talk to this model quite often, then you might need to take this model out of the multi-model endpoint and host it in a dedicated endpoint. So this is one of the best practices that you need to test and cater for. Also, multi-modal endpoints are well suited for scenarios that can tolerate occasional cold start, because if there's a model that is not currently loaded in memory and you started to talk to it, we will take some time to free up part of the memory from another model that is not frequently accessed, and then load that model into the memory. So there's a really small overhead here that you need to cater for. The second option is, well, before going to the second option, this is how it looks like from a code perspective. You need to provide a location for all of your models in an S3 bucket. You need to specify that you have multi-model mode in your endpoint. Create the model, pass in all of the containers, create the endpoint configuration, and then when you invoke that model, you need to specify a target model that you need to talk to directly in this endpoint. So a very straightforward way to deploy it. The second option that I mentioned is multi-container endpoint. So multi-container endpoint, on the other hand, can host up to 15 different containers, meaning that you can have diverse machine learning frameworks and functionalities across all of these containers and models. You can host up to 15 models for what we call direct invocation or serial invocation. So for direct invocation, you literally talk to the container, or when you make a request, you send that request to the specific container that you want to talk to. And then serial invocation, and otherwise we call it inference pipeline, that's basically going to talk all of the models in the containers in a certain sequence. It is really ideal if you'd like to combine pre-processing with model inference, for example. So you want to pre-process your data inside the inference, do something like dimensionality reduction, and then maybe classification model inference, so 3 different containers. And the good thing is you can have each single container can have a complete different framework than the other one. And because all of the containers are running at the same time, there's no cold start issue at all. Again, to set up, you need to specify all of the containers that you want to have or host behind this endpoint. You need to specify the mode, so either direct or serial, and create the endpoint configuration, create the endpoints, and then when you invoke it, if it's direct, you need to specify the container that you want to talk to. If it is serial, you don't need to specify any container, and it's going to follow the sequence that you provided here in the containers when you define that containers construct. Okay, so those were all of the deployment options that you can use within Amazon SageMaker. Now, for endpoint performance measured by latency and throughput, one of the major factors is the instance of choice. So in SageMaker, you get a wide range of instances or instance options to choose from, and they fall under 3 different categories. One is CPU instances, which is basically give you low cost, low latency, and quite flexible in terms of supporting diverse machine learning frameworks. And on the other hand, it does not really give you high throughput for some certain situations, for some certain machine learning models. And that's where the second option comes in place. So the GPU instances are quite optimal for high throughput, low latency, and but at the same time, you can only benefit from the models, or the models that can benefit from GPUs are the ones that supports GPU processing, like deep learning models. And the last one is the Inference instances that comes with a custom Inference chip. They have about 2.3 times higher throughput they can give you up to 70% lower cost and high throughputs, ultra low kind of latency compared to GPUs. And before you start using Inference chips, you need to make sure that you have supported frameworks, because it supports some certain frameworks that use for building these models, and custom operators inside the model itself. So just make sure that you also cover that part. So with all of these options discussed, still the question remains, how do I even know what instance and what endpoint configurations is optimal for my endpoint? And now the way to achieve this is to do load testing. So load testing is basically the practice of sending a whole bunch of artificial traffic to your endpoint to see how it's going to hold up. And understand the performance characteristics as a function of traffic size, instance type, and instance count. And then in the context of inference endpoint, this diagram is showing you the whole process. So what happens is you have an endpoint, you have load balancing, and then load balancing goes to a whole bunch of EC2 instances behind the endpoint. And then once you start sending traffic, all of these endpoints is going to scale out to start handling the traffic. And all of the data of your experiment is going to go to Amazon CloudWatch. So you'll be able to see stuff like model latency, number of invocations, how much each invocation took to finalize or finish, and so on. And you should be able you should be in a much better position to decide what would be the right instance type for you. Here's a really good dashboard that we created that after we did some experiments, or load testing experiments, on 2 different instance types. So we have the C5-2X large here, and a C5X large. And you can see we get information like model latency, number of invocations, the overhead latency, model loading time, and so on. And then you can see here that the CPU utilization in the C5X large was sitting at 100% all of the time. And then memory utilization was around 70%. Whereas the C5-2X large, you're around 60% for CPU utilization. So it might be a good idea to just go for the C5-2X large in that case. And also you can see the model latency here is much lower in the C5-2X large. So if this is what you're looking for, then go for this specific instance. But the idea here is that you get comprehensive amount of information to make that decision of what will be the right instance type. Okay, now that we got all of the deployment options out of the way, let's have a look at what the decision process is going to look like. Let's build some kind of mind map to summarize all of these options and make it a bit easy for us to remember. So let's ask ourselves, do you have live predictions, so live traffic coming through? If no, then batch transform is going to be the solution for you. If yes, you got to ask yourself that question: can you tolerate cold start? If yes, is your payload more than 6 megabytes or more than 60 seconds? If no, then serverless inference is a good option here. If yes, then you might need to think about SageMaker's asynchronous inference. Now, if you cannot tolerate cold start, we need to ask ourselves, do you have multiple models and containers? If no, excuse me. If no, then use SageMaker real-time endpoint. If yes, then think, do I have multiple frameworks or not? If yes, then multimodal endpoint. If no, then multi-container endpoint is the right option. And then eventually you'd like to do some kind of load testing for all of these options. Or no matter what option you choose, you're going to need to do load testing. Excuse me. Notice that I don't have a line going from serverless inference to load testing, and that's basically because you define the capacity that you'd like to have in a serverless manner, And then we automatically scale in and out the resources behind the scenes for you when you send more traffic. And then if you have fluctuating traffic, for all of these options, you can set up automatic scaling group to handle the increasing amount of traffic. So that's a good mind map that summarizes everything that we discussed. So besides optimizing your models for performance and cost, it's really equally important, if not even more important, to optimize for model accuracy after it goes live. So SageMaker model monitoring enables you to monitor drift in 4 different modes: model drift, model quality drift, data drift, feature importance drift, and bias drift on your data. In the first mode, monitoring the performance of a model we just look at the model after you put it into an endpoint by comparing the predictions that the model makes with the actual ground truth label that the model attempts to predict. So we set up a processing job at a certain schedule, and we do that statistical comparison between the actual label and what the model predicted from the ground truth. And we send all of the information to Amazon CloudWatch so that you can have some kind of view over time how the model performance deteriorated and whether or not your model is performing as when you trained it. But sometimes you don't have the ground truth. Sometimes the ground truth is not available for you right away. And that's when you can use the second mode, which is data drift. So for data drift, what we do is during training time, we run a job that calculates a lot of statistical information or statistical distribution about your data, and then keep that with the timestamp somewhere. And then after that, we capture all of the information that you send to your endpoint, and then periodically compare this information. So we compare the statistical distribution of your inference with the statistical distribution of the model during training. And then if we notice that there's a big variation between these two, we give you an alarm or we show you in a dashboard that your model started to drift or your data started to drift away from the baseline, and that might be a good time to retrain your model. Last but not least, SageMaker model monitoring can compute the feature importance or the feature attributions changes and data bias changes in the incoming data. And then with the help of SageMaker Clarify, which is another component that lives in that space of the SageMaker deployment, can tell if it's the time for the model to retrain in order to maintain model accuracy by checking how the model is making decisions. Okay? Now, with the next iteration of your model, we might need to think about how to verify the performance against the latest and last working model. And in order to do that, you need to conduct some kind of A/B testing. So conducting A/B testing with SageMaker is quite an easy process. You don't need to bring down the model, the endpoint, in order to add a new production variant. All you need to do is just call the right API call, and then this is going to add another version of the model behind the same endpoint. And then after that, you can specify some kind of weights, saying that, for example, I'd like to redirect or give 10% of the traffic to the new model, and then keep 90% of the traffic to the old model. And then all of the information about the invocation will also go to CloudWatch. And then you can set up some kind of rule that extracts based on the objective that you would like to achieve. So it could be conversion rate, it could be anything that you'd like to test your model for. The idea here is that SageMaker is going to automatically manage distributing the traffic based on the weights that you specify here. And you can change all of these weights on the fly without having to bring down this endpoint. So you must be wondering, what if, like we're talking machine learning here, is there any way to automatically try to decide for me what would be the best ideal kind of instance that I should host behind my endpoint? The answer is yes, we do. So Inference Recommender is a service that we recently released. It helps you choose the best available compute instances in configuration to deploy your machine learning models. And it also selects the best optimal inference performance based on dimensions that you can specify. I'm going to show you a quick demo here. So this is basically a notebook that pulls down a specific model. So in this case, I'm downloading a model that is ResNet 50. For you who's not familiar with that model, it's a computer vision model that has 50 layers of neural networks. We compress, put that model in a file, and then I generate to download some sample payloads, so a few images that I'd like to make inference against this model or use to make an inference. And that's all you need. So package your model, generate some samples that you would like to send to or give it to the inference recommender, and then create a client, create a inference recommender job, pass in a few simple information here, including the job type, which is either default or advanced. And then you're going to get some results. So what we do in the backend, we try multiple different variations of instances and different configurations, and we tell you information about this specific instance if you're going to host it with this configuration. So you can see the cost per hour, the cost per inference, the maximum number of invocations that you can do at any given time, and so on. Now, I told you there are two different options, so the default and the advanced. So this is the advanced one, which allows you to give a whole more information to the inference recommender before it makes any decisions. So you can tell it, for example, I'd like to make some kind of tuning for the configuration and the parameters of the endpoint and give it a range. And then it will try this specific range and see what will be the best optimal combination of all of these configurations plus the inference or the instance size, and then give you data about it. Another really cool view is that you'll be able to see the cost per hour when we carry out this test. And you see in the table down here, all of the costs versus the model latency. You might also choose what dimension you'd like to prioritize. Something like, I'd like to prioritize the cost, or prioritize latency, or I'd like to have a bit of mix, like medium cost, high latency, and so on. And then this is automatically going to select the right instance for you and show you the model latency if you'd like, if you're going to use the combination of the configuration plus the instance size. And with that, I'd like to introduce Alberto to the stage. Welcome, Alberto. He's going to talk to you about Docebo journey for using SageMaker. Thank you.
Thank you. Can you hear me? OK. So I'm Alberto. I work from Docebo. Today, I'll explain you how a Docebo team without any particular knowledge in machine learning was able to take a pre-trained model and deploy it in production in a matter of a month, more or less. So Docebo is an Italian-Canadian company born in 2005. It has a learning suite that is composed by multiple products to help our customers organize, deliver, and create content for their training programs. One of the applications that is part of Docebo Learning Suite is Shape. With Shape, our customers can plug in their source of information, so any kind of source material like documents, web links, and so on. And the AI behind Shape will extract the most important concepts from the source and will create, in a totally automated way, an e-learning pill, so a micro-learning content starting from the document without the intervention of the user. the user can use the built-in editor to edit and change something, and then can deploy and deliver the content in his preferred channel. How AI behind Shape works? So we have 3 different models. The first one is responsible for extract the text from the document, for example. The second one does an abstractive summarization. So it extracts the most important concepts from the source, while the third one search for keywords that are used by Shape to enrich the content with visuals like images or videos. All these models are orchestrated by the Shape platform with a state machine with AWS step function. On the left here, you can see the lambdas that simply triggers the calls to Kubeflow in a Kubernetes pod. On the left, so the Shape team is responsible only for the left part, because we had computer scientists and machine learning operation experts that are responsible for the models. We had a problem because the distiller service was simply not reliable. And the Shape team had to find a way, because the AI team was overwhelmed with a lot of other requests. So we, as Shape team, without any particular knowledge in machine learning, had to find a new model to solve these errors. We had some errors, for example, with the particular types of documents. The output of the distiller, so the text extraction service, was flat. It didn't keep the structure, for example, if a portion of the text is a title, a paragraph, a list, and so on. There was not good monitoring. It was quite lacking. And the solution we built for deployment was not very reliable. We had some issues while deploying the service. That's why we started looking for another model, and we found a pre-trained computer vision model for document layout analysis. Basically, the model detects all different blocks inside a document, and with a percentage of confidence, it understands if this is a list, if this is a text, if those are notes, and so on. We tried to improve a bit the model, adding some other information, like resolving colliding boxes, remove noise, and so on. We had the model, and it was suitable for our use case, but we never deployed the model. So we had to find a way to do that. And fortunately, we found SageMaker. So we needed a managed solution to deploy, monitor, and manage the model in our production environment. All the infrastructure behind Shape is managed with the AWS CDK. That is a framework with which you can create all your infrastructure with your preferred programming language. So we use the CDK also to create the resources involved for this new computer vision model that will substitute our distiller service. Basically, we created different stacks. Each stack is responsible for creating resources in our AWS account. For example, here you can find the base stack that provides the basic functionalities that is extended by the model serving stack that is responsible for serving the endpoint with its configuration, the model archiving stack that is responsible for uploading the model files to S3, and then the monitor dashboard stack, in which we created all the configuration used by CloudWatch for logging and for the alarms. Here you can find the project structure. We structured the project with 3 different layers. So the first one are the code created by our cloud architects to create all the resources in in the cloud, so in our AWS account. The second one, codes Lambda, instead is the code that our developers write down. And the third one is is the model with its related scripts that our computer scientists, once they were free to work on this project, could work on. On top of those three layers, we have an app.config.json. This is very important because later I'll show you how to configure and to fine-tune the model and the inference and so on. Here you can find how the inference with SageMaker endpoint, the real-time inference works in our case. Basically, we needed to prepare two different things. The first one, all in the same compressed file. The first one was the PyTorch model files, and the other are the related code scripts for that model. Automatically, once the inference starts, SageMaker start the Docker containerization, then install the dependencies from the requirements.txt, and then it calls the scripts, the functions in the inference.python scripts. So the input, predict, and the output. Here you can find some configuration for the SageMaker endpoint. Basically, the configuration, for example, about the instance type. We ran a few load tests to understand what was the best instance type for us. Will already spoke about that, so I don't go too much in detail, but we chose for AWS Inference. Here you can find some cool configuration in that JSON file that I mentioned before. For example, how to deploy multiple models behind the same endpoint for A/B testing. We had to deploy two different models, and then we fine-tune a bit the traffic between the two. And here we have the automatic scaling. It was really nice to try a bit what was the best configuration for us. Here you can see sample values. Those are not the ones that we are using in production, but it's really, really easy to configure the auto-scaling with the capacity and the number of instances. Since we are using CDK, it was also really, really helpful. It was really helpful and really easy to configure the scripts for the deployment. CDK provides the CDK deploy commands that will deploy all the stacks, so all the resources on CloudFormation with CloudFormation. Basically, you write your own code, in our case in TypeScript, but you can do it also in Python. And CDK converts all that code in a CloudFormation template, and then you can create the resources on AWS. Here, for example, we created a command to compress the model files and then to run the deploy for each model and for the other stacks. At the end of the day, what we learned, without any particular knowledge, we were able to bring up a running endpoint for inference in a matter of few hours. In less than 1 month, we were able to have this model working. CloudWatch was very useful because it gave us the ability to monitor the load on the endpoint and the status of the model in nearly real time. Sorry. And CDK for us was really, really useful to create all the infrastructure behind our project. What's next? We aim to migrate also the other two Shape AI models to SageMaker endpoint because it was an awesome journey. We want to migrate also from GitHub Actions for our release pipeline to code pipeline to have a more integrated release experience within the AWS environment. And then we want to test serverless SageMaker endpoint to reduce cost and to optimize everything. That's all. Thank you.
Micro? Thank you so much, Alberto. I think this is a wonderful example of how some of our most mature customers are really taking their decisions and driving value from machine learning. So there's nothing more left for me than to wrap up here. What did we cover today? We talked a bit about why this is an important topic. We talked about SageMaker deployment strategies, talked about inference load testing, A/B testing, model monitoring, and lastly we had that example from Alberto about Docebo's journey with Amazon SageMaker. Now, I hope we get you a little bit excited. If you want to learn more, here's some of the learning programs. We have the AWS Skill Builder with access to 500 plus free digital courses in over 16 languages. We also have our AWS certifications where you can get yourself certified. It's an ML specialty certification, for instance, or the developer associate. It might be a good start to learn more about these setups. Thank you very much. I hope you had a good time with us today. Please do me a favor and fill out the survey. We use that information to make our talks consistently better and hopefully drive more value out of this for you going forward.